In this video, we will give an introduction to calculation of means and standard deviations. What does a mean or standard deviation measure? Our goal is to give a general overview of these statistics, focusing on the big picture. Basically, a mean measures the location of the center of a data set or distribution. In a sense, the mean describes a typical value of the set. A standard deviation measures the spread of a data set or distribution. It describes how far, on average, the data values are from the mean. How these are calculated depends on the nature of the distribution. Recall that parameters are fixed numbers describing a population, and statistics are variable numbers calculated from a particular sample. It is useful to review the notation used for means and standard deviations. We use the capital letter N for the number of individuals in a population, and we use a lowercase n for the number of individuals in a sample. We use a lowercase Greek mu for the population mean, and we use x bar for a sample mean. Finally, we use a lowercase Greek sigma for population standard deviation and a lowercase s for a sample standard deviation. Note that mu is the Greek m and sigma is the Greek s. To understand the formulas for calculating means and standard deviations, we need a bit of mathematical notation. Let's consider summation notation. For a set of n observations called x1, x2 out to xn, the summation from I equal 1 to n of xi means the sum of x1 plus x2 plus on out to xn. Let's look at one example. For the 5 observations, 1, 3, 4, 6, and 8, we have that x1 is 1, x2 is 3, x3 is 4, x4 is 6, and x5 is 8. So x, little x, denotes an observation, and the subscripts 1, 2, 3, 4, 5 denote if it's the first, second, third, fourth, or fifth, and then that equals whatever the value is. Also, the sum as I goes from 1 to 5 of the xi's is you take first x1, which is 1, plus x2, which is 3, plus x3, which is 4, until you get out to x5. You add those numbers up. So we get 22. Essentially, a giant Greek capital sigma means add up or sum a bunch of values. These symbols will occur in our formulas. Now let's discuss the formulas for the mean and standard deviation of a set of numerical data. There are slightly different formulas for standard deviation depending on whether the observations comprise the entire population or only a sample. Let's first consider the case in which the observations come from the entire population. This would be the case, for example, if the data set was a set of all test scores from a particular class on a particular exam. For a set of capital N observations, x1 out to xn, the mean is given by mu equals, you sum or add the values of the x's and divide by the number n of them. The standard deviation is given by sigma equals a big square root. In the numerator, you sum xi minus the mean squared, and divide by n. Remember that the standard deviation is going to tell you how far on average your data values are from the mean. So we want to subtract our data values minus the mean. Let's look at one hand calculation for illustration only. Note that people do not calculate these values using these formulas directly. Most people nowadays use software, as we will see shortly. For the 5 observations we considered earlier, 1, 3, 4, 6, and 8, the mean is the sum of the values divided by 5. The sum of the values is 22. Divided by 5 is 4.4. So the mean is 4.4. The standard deviation is sigma equals, we have a big square root. We add up the difference between the observation and the mean, and we square that. Then we add, divide by 5. Basically, we want to calculate how far, on average, each individual observation is from the mean. If we subtract the xi minus the mean 4.4, some of these differences will be positive and some will be negative. So adding them will cause some canceling. That's why we square the differences before adding them and dividing by 5. But because we've squared, we take the square root to sort of undo the squaring that we did earlier. At any rate, we see those differences squared and being summed in this formula. The arithmetic produces a big square root of 29.2 divided by 5. This is equal to the square root of 5.84, which is approximately 2.4166. Remember, this example is for illustration only. We'll use technology shortly to compute these values directly from the observed data. Now let's consider how to calculate the mean and standard deviation for a set of observations that represent a sample instead of the entire population. In this case, we would have small n observations, and the sample mean is denoted by x bar, but the calculation is the same as before. Sum the observation and divide by the number of observations. The sample standard deviation is denoted by a small s and is calculated almost as before. The only difference is that we divide by n minus 1 instead of dividing by n. Remember that one of the primary uses of statistics is to use a sample statistic to estimate an unknown population parameter. When we use a sample standard deviation to approximate a population standard deviation, the approximation is better when dividing by n minus 1 instead of n. For this series of videos on statistics, I will utilize the TI-84 Plus graphing calculator as my technology for statistical calculations. I prefer using this calculator to computer software because the calculator is small, portable, and doesn't require any internet connectivity. It's also relatively inexpensive and readily available. There's a stat key that I've indicated with a red arrow. When you push stat, you get 3 menus. One is edit, one is calc, and one is test. You can see on this slide that each menu has a list of options. We're going to use edit and calc menus now and save the test menu for later videos. Notice that option 1 under Calc is to compute one variable statistics. The statistical features of the calculator mostly require that we have our data set input into one of several lists. Under the Edit menu, choose option 1, Edit. This brings up a list environment. I've put our previous 5 data points in List 1, L1, which stands for List 1. On my calculator, I also have some data in Lists 2 and 3, but we won't use them right now. With my data in List 1, I want to compute one variable statistics for this list. Under the Calc or Calculate menu, I selected option 1, one variable statistics. I also need to tell the calculator which data set to use. So I'm calculating one variable statistics on List 1. The calculator output is shown in the third screenshot. Notice the mean, x bar, is 4.4. And both forms of the standard deviation are shown. Sx is 2.70185, etc. And sigma for these x values is 2.4166, etc. We would use the S standard deviation if our data represented a sample, and if the data represented the entire population, we would use sigma as 2.4166. You might recall that 2.4166 was the approximate value we got when we calculated sigma directly from the formula.